vision of providing quality education to students of various strata of the society, the founding stone of Tuljaram Chaturchand College, Baramati, were kept in the year 1962. The college has been formed with the efforts of numerous people.
Our society is a religious minority institute, and we thrive well with the preamble of Siddhir Nikantana, means knowledge from all the dimensions.
119 विद्यार्थ्यांना कॉलेज सुरू झालेलं. आज जवळजवळ 12,000 विद्यार्थ्यांवर पोहोचलेलं आहे. हे कॉलेज ग्रामीण भागातलं सगळ्यात मोठं कॉलेज म्हणून आज गणलं जात आहे.
The college is affiliated to Savitribai Phule Pune University.
We are willing to empower the youth to skill and career-oriented educational and vocational programs so that he will be full-fledged for grabbing the opportunities for his career.
The college has well-qualified team of experienced teaching staff who are always ready to help, assist, guide, and motivate the students. Regular meetings are conducted to keep a track of the development of the students and to plan new activities for their growth. Providing various streams of education under one roof makes Tuljaram Chaturchand College a renowned academic institution. With such numerous courses being provided in the college, the administrative department continuously and promptly maintains a smooth flow of activities in a well-managed manner. The college focuses on imparting career-oriented quality education at par with global standard. The senior college offers 3 streams: arts, commerce, and science. The college offers 22 different courses for graduation as well as post-graduation in various departments like Geography Department, Psychology Department, Yoga Department, Bachelor of Vocation Program of UGC in 2 disciplines: Food Processing and Post-Harvest Technology, and Journalism and Mass Communication. The college has well-equipped laboratories where students, under the guidance of their professors, learn and conduct various experiments. The Electronics Department in the research arena. The Botany Department had set up their own botanical garden. Well-equipped biology labs. IT Department has well-equipped computer lab with Wi-Fi internet facility where students can develop their computer science skills. The classrooms are well designed with projection facilities, and the students are encouraged to have better understanding of their subject with friendly interaction with the teachers. The college campus is built with a central library which has a huge setup of numerous books of various streams. Student can access the library and read on various subjects to gain an in-detail knowledge. There is a reading hall adjoined to the library where the students can peacefully study and take note on various topics of their interest. If a student wants to get some additional information on this subject, T.C.College also provides an internet cafe. The college has a huge auditorium, Jivraj Sabhagriha, with all the modern facilities, where around the year numerous events and functions are conducted for cultural educational growth of the students. Along with academics, The college has given equal importance to physical development of the student by providing innumerable sports activities like volleyball for boys and girls, kabaddi, basketball, boxing for boys and girls. The college has trained and developed some great sports persons who have won remarkable awards on various national and international platforms. The college provides NCC training where the cadets are given basic military training in small arms and parades. The cadets are well trained and given preference over normal candidates during selections. The officers provide good training and disciplined education to the students. The NSS activities are conducted by the students like street plays to bring awareness in the society. Plantation, construction of bunds and many others. And for these activities, the college has received various recognition and awards for their contribution towards society. Since 41 years, the college has been organizing a Moropanth elocution and debating competition every year, which is a state-level competition. The college publishes an annual magazine called Anekan to motivate the creative skills of our students by providing a platform where they can publish their poems, articles, and their opinions.
या संस्थेची प्रगती करत असताना आम्ही MBA कॉलेजची नवीन बिल्डिंग बांधतो. अनेकांत इंग्लिश मिडियम स्कूल म्हणून नवीन बिल्डिंग बांधून त्या ठिकाणी सुरुवात केली. या ग्रामीण भागामध्ये हे कॉलेज सुरू होत असताना इथल्या मुलींची निश्चितपणे एक चांगल्यापैकी व्यवस्था झाल्याशिवाय राहणार नाही. कारण सहसा मुली बाहेरगावी पाठवायला पालक तयार नसतात. पण हे कॉलेज सुरू झाले म्हणजे त्या मुलींना चांगल्या शिक्षणाचं दार उपलब्ध करून देण्यासारखं होईल.
स्त्रियांच्या आरोग्यावर शिबिरं आयोजित केली जातात.
The college also fulfills its social responsibility by conducting various events of awareness and confidence building in women. And to build a healthy environment, it also conducts the activity of plantation. The institute has also received various government funds for its welfare and further development.
Our institute is NAC re-accredited with a B grade. Also, we have undergone ISO certification 9001. The college has received the funding for DST Physics program. The institute is recipient of Star College status from DBT.
The college has also got various funds like College with Potential for Excellence and has won many recognition and awards in various fields.
We are seeking that the student should be at the excellence at par, not only in academics but in other activities like sports, competitive career, as well as the vocational skills.
The teaching department over here is very much friendly. We have a library which includes books from all the streams.
We have achieved many prizes of national and state level.
The college has boosted our confidence. The computer science department of a college has well-equipped laboratory.
The teaching staff here is good at transforming student attitude and creating better individuals.
The days are not far ahead that this institute will be a benchmark not only in Maharashtra or India but at the global scenario.
This is the journey of Tuljaram Chaturchand College, where it has enriched and nurtured hidden talent of students from various strata of the society and transformed them into confident and responsible citizens to excel in all walks of life.
Good morning everyone.
myself Dr. Rahul Bondwe, it gives me immense pleasure to welcome you all to this 2 days international webinar on research trends and opportunities in chemistry, organized by Department of Chemistry, Tuzaram Chaturchand College, Baramati, in association with RUSA, that is Rashtriya Uchchatar Shiksha Abhiyan. Friends, 21st century is known as era of information technology. But during this COVID-19 situation, scientific gatherings, workshops and symposia have many restrictions. So, during this time, webinars became the primary and most popular source of scientific gatherings, where researchers from India and abroad can share their views, ideas and also the recent informations. During this pandemic situation of COVID-19, world has suffered a lot, but on the other hand, we have seen overnight revolutions in science and technology. Friends, main goal of this webinar is to update our students with these recent and changing trends of research, whereas preparing them for the next challenges by showing them new opportunities. Friends, let me introduce our department. Department of Chemistry is established in 1962, where principal subject was chemistry. As time passes, in 1994, department started Masters in Inorganic Chemistry, followed by in 2008 and 2006, department started Masters in Organic Chemistry and Masters in Analytical Chemistry. Department of Chemistry have 5 well-equipped laboratories with advanced instruments like FTIR, HPLC, GC, UV and AS. Friends, it is one of the largest department in college, whereas the only department in SPPU, that is Savitribai Phule Pune University, having 3 specialization in MSc. So now I request our Honorable Principal Dr. Murumkar Sir, convener of this 2 days international webinar, to address our students and participants. Thank you.
Welcome to Anikant Education Society's Tuzaram Chaturchand College. Dear friends, it gives me great pleasure to welcome you all to join an international webinar organized by the Department of Chemistry of this college. I am very much happy that Professor Sanjay Kale and Dr. Bondwe have taken great pains to make this international event a success. I am very much sure that Department of Chemistry, when they have thought of organizing an international webinar on the topic research trends and opportunities in chemistry, I am sure that each and everyone who has joined this whole international program will be happy to know what is happening on the fronts of chemistry. Dear friends, in this international webinar, we have got a galaxy of scientists who are coming all the way at global level of a repute. Honorable Dr. Harichandra Tagat, Dr. Vinayak Kale, Dr. Ajay Srivastava and Dr. Ramesh Datir, they will be contributing in this international webinar as the resource persons. Well, all these giant personalities are coming from the new world with a new era, right from the USA to Abu Dhabi and Saudi Arabia, and many are from CDRI Lucknow. The issue which has been raised through this international webinar is to familiarize the new technologies which have been introduced in not only the field of chemistry, but the interactive fields of chemistry, physics, and obviously the biosciences. Dear friends, today's research and the professional approach of the modern world is totally based on technology. And today, the technology means not only the instrumentation, but the technology means its cooperation and its support from the digital support at the same time. Dear friends, today's research is a technological know-how, and because of that, obviously, when we are entering into the 21st century, we are entering into a new world of green chemistry. This green chemistry is a must for each and everyone, because this is the way we are going to give a new future for the coming generations. Dear friends, the 20th century definitely has given a lot of impetus in the developmental chemistry in all our nooks and corners of the life. But we have seen the side effects of this development, and now we have become wiser enough to understand where we fall short. Definitely in 21st century, we are going to make these shortcomings a truth and going ahead with leaps and bounds with the new technology which may encompass the green chemistry. Obviously, the green chemistry is in need of time, and I hope that such a type of international webinar will be throwing more light in the issues which are raised in the chemistry, the opportunities which are available in the chemistry, and technological know-how from the chemistry, and at the same time we'll be going ahead with the more and more approach of the recent trends which are coming, where we are using the biological material, we are using the biological sciences in the terms of chemistry, in the terms of computational sciences, and going ahead and seeing that we are having a safer world, we are having a safer future, and at the end we are having the green chemistry at the hands of next generation. I wish you all a grand success and hope that such a type of webinar will be definitely giving us a new impetus to start with. Have a great day and enjoy this international webinar. Thank you. Have a great time.
Good morning, all the attendees, and thank you so much, sir. Myself, K.M. Rupnavar from Department of Chemistry, and I welcome you all in today's webinar. And I am here to introduce our first speaker. And it's my pleasure to introduce our first speaker, Dr. Tagad Harishchandra sir. Sir is a scientist in NIH Institute, USA. He has completed his BSc in 2003 from Sri Dnyaneshwar Mahavidyalaya, University of Pune, Maharashtra. Then he has completed his master degree from Ferguson College in 2005. Then he went to the National Chemical Laboratory. After that, for the further research work or the PhD, he went to the Kyoto Pharmaceutical University, Japan. Then, after completion of PhD in 2011, he went to the National Cancer Institute, NIH, USA. He worked there as a postdoctoral research fellow, and up to 2018 he has worked there, and from 2018 to 2019 he worked as a scientist there. And from 2019 to present, he is working as a research fellow in the same institute. His main research interest is in the medicinal chemistry, and he is working on the interface between chemical biology and the medicinal chemistry. He has a number of research papers and the patents on his name, and his main research interest in the medicinal chemistry, his expertise in the design and multi-step molecule synthesis and peptide-based inhibitors targeting PPIs. So, I welcome Dr. Tagad sir in today's webinar, and I want to request Dr. Tagad sir to start his presentation.
Good morning, everyone. First, I would like to thank the organizing committee of T.C.College for giving me an opportunity to present my research work and share some of my research experience I have been through. Also, thank you Dr. Rahul Bondwe for a brief introduction. My name is Harichandra Tagad and I'm currently working at the Laboratory of Cell Biology in NCI branch at NIH in the USA. Today, I am going to talk about my research and educational background, a journey starting from India to US via Japan. I hope my experience and research will help you make your choices along the way. So let's get started. Before I jump into my educational and research background, let me introduce to you about myself. Basically, I am a medicinal chemist working on a small molecule or peptide-based therapeutic development targeting enzyme involved in disease progression. My research is centered at the interface between medicinal chemistry and chemical biology. For close to 9 years, I am in the US, and as I said earlier, my research is focused on design, synthesis, and development of inhibitors targeting protein interactions which are involved in cancer progression. So, in the first part of my talk, I would like to briefly mention about my educational background, and then I will talk about current trends and ongoing research, especially in chemistry. Followed by, I will provide you an ample information on what are the opportunities in chemistry, how one can make a transition from master degree to a doctoral degree or other professions of interest. Also, I would like to give you a little bit information on career opportunities in and outside science. As you can see here, I did my master in organic chemistry from Ferguson College. Upon completion of my master degree, I worked at the National Chemical Laboratory in the Department of Chemical Engineering and Process Development, where I had a real taste of practical organic chemistry. At NCL, I acquired experience in multi-step synthesis of organophosphorus compounds and small drug molecule development. I worked at an NCL almost for 2.5 years before joining to my PhD. In 2008, I joined for a doctoral course at the Medicinal Chemistry Department at Kyoto Pharmaceutical University in Japan. In my PhD, I worked on substrate-based design, development of aspartic protease inhibitors targeting base-1 enzyme. During this time, I developed novel, small size and more drug-like peptidomimetic inhibitors. After successful completion of my doctoral degree in 2011, I joined Laboratory of Cell Biology at National Cancer Institute in National Institutes of Health, US, as a postdoctoral visiting fellow in 2012, where I am currently continuing my research in medicinal chemistry. As a postdoctoral fellow, I worked on small molecule and peptide-based inhibitor development against VIP1 phosphatase. So, I will give a brief idea about my research which I carried out during my PhD and postdoctoral fellowship. Although my most of the of talk will be cover a medicinal chemistry and chemical biology aspects, but I think this will be very helpful to understand the basic principles of biology and how it can be used to understand the biological pathways and target these pathways or protein-protein interactions involved in a disease development through medicinal chemistry point of view. So, as we see that although we divide science into different fields, there is a much overlap among them, especially when it comes to the chemistry, which lies more or less in the middle of the other branches of science, which emphasizes its importance to many branches of science. For example, some biologists and chemists work in both fields so much that their work is called biochemistry. I will show you one such example with my outline of research, which basically deals with the addressing biological questions through chemistry point of view. Before I discuss my PhD work, let's go through this interesting clip first, which will provide you how biology and chemistry are interconnected. This is a clip which provides you the biological pathways involved in Alzheimer's disease. So let's see the clip.
The human brain is a remarkable organ.
So here you might have noticed that if you have seen the overall amalgamic pathway which has been explained in this video, as you might have noticed that this basically deals with the amyloid precursor protein which gets cleaved by an enzyme which is a base one in Alzheimer's disease, so which provided a molecular basis of amyloid beta biology. Now let's correlate this with chemistry and how one can translate into chemistry point of view. So in the video, the biological point of view which we have seen, as you know that living cell is a dynamic complex system where biological processes such as signaling pathways shown in this video are mediated by changes in highly selective non-covalent or covalent interactions between biomolecules such as base 1 protein which cleaves amyloid precursor protein at a specific amino acid sequence. Understanding this interaction at a molecular level is crucial for understanding of how the living cells function upon impairment of the protein-protein interaction, which leads to the disease progression such as Alzheimer. So, thus understanding these interactions at a molecular level could provide the background for the development of drugs that will selectively inhibit undesired interactions or will restore appropriate protein function to the normal. And this is more sort of biology. But let me explain you in a better way as a chemist so that everyone can understand. So as shown here, where with a biological point of view, in the normal way with non-amalgamic pathway, this amyloid precursor protein is initially cleaved by alpha secretase, which results into a soluble S-APP alpha fragment, whereas the second cleavage by gamma secretase leads to the P3 fragment. But on the other hand, when it comes to the amylogenic pathway, where this membrane-bound amyloid precursor protein initially gets cleaved by base 1, which is beta site APP cleaving enzyme, which results into this soluble S-APP beta, followed by a gamma secretase cleavage results into a beta peptide. This peptides further undergoes oligomerization and gets aggregated inside the brain. So thus, base 1 is one of the rate limiting stage in the formation of this A beta peptide. So in theory, if you inhibit the base 1 activity, which can result to halt the progress of Alzheimer's disease. And so inhibition of base 1 is considered as a promising therapeutic target for lowering A beta level in treatment. So how it can be done? So as we see the biological point of view of this pathway, now how we can convert into chemistry for biology. So the base 1 which cleaves this amyloid precursor protein at an amino acid which has been shown here with wild type APP sequence. In this sequence, base 1 cleaves at in between methionine and aspartic acid and which results into the formation of this A beta peptide. And this cleavage is basically carried out by using two aspartic acid residue of the base 1 and with the help of water molecule which cleaves this peptide bond via such an tetrahedral substrate transition state. Based on this substrate transition state, a transition state analogs can be designed and developed to inhibit the activity of this base 1 enzyme. Using this terminology, initially for the first time in in 2000, a substrate transition state mimic peptide was developed by using hydroxyethylene transition state which showed high inhibition potency with 1.6 nanomolar. When I started my PhD work, I was interested in developing similar types of inhibitors by using different substrate transition states. And so, with the same terminology, I developed various types of analogs as shown here in this slide where I started my the research started with the development of earlier reported KMI 358 inhibitors. And this is the overall outline of my PhD work where I performed a systematic analysis of earlier reported pentapeptidic inhibitors by modifying its P4 and P1 prime position with various types of analogs. In first section, I modified this carboxylic acid to a tetrazole moiety, whereas for P4 position, I also used the tetrazole carboxylic acid to develop a new pentapeptide with improved inhibition potency with IC50 3.3 nanomolar. So the idea behind developing this carboxylic acid bias was to not only improve the inhibition potency of this series of peptide, but also to have an inhibitor with a good pharmacokinetics and good blood-brain permeability. As Alzheimer's disease is associated with the brain, so it's very important that the inhibitor should cross the blood-brain barrier to target the base 1 enzyme. In second part, I modified P1 prime position with 1-phenyl cycloalkyl derivatives where the most potent inhibitor of the series which has P1 prime position with 1-phenyl cyclopentyl amine moiety, whereas for the P4 position I varied various types of electron withdrawing or donating moieties as such 5-fluoroortyl which is shown here, and this compound which showed IC50 11.6 nanomolar. But to be a practical anti-Alzheimer drug, it's also important that the size of the peptide or small molecule should be appropriate so that it will have good pharmacokinetics as well as good membrane permeability. So in this respect, I wanted to develop a small size inhibitors which were like tetrapeptides or tripeptides based on earlier designed pentapeptides. And so to do so, I developed a tetra and tripeptidomimetic inhibitors with deletion of P1 prime position and modification at the P1 position. Although on reducing the size of these peptides, which results into decrease in the inhibition potency, but this laid and foundation for future development of small molecule inhibitors targeting base 1. So during my PhD, I have developed a number of inhibitors to achieve a practical anti-Alzheimer drug. I will not go into the details of the synthesis part or how we tested these molecules. Instead, I will move directly to my postdoctoral work. So in my postdoctoral work, I am basically working with VIP1 inhibitors development. So VIP1 is one of the phosphatase which has been shown to be involved in various types of cancers. So before going into the details, let's understand some of the basic terms as shown here in this slide. So first is what is the phosphatase. So phosphatase are the proteins which dephosphorylates the protein, and on the other hand kinases which act in an opposite fashion by phosphorylating the protein with the help of ATP molecule. And this transformation of phosphatase or kinases needs to be balanced for various cellular processes. Now, what if, let's say, VIP1 phosphatase gets overexpressed? Basically, it will dephosphorylate other proteins in a high extent and which are critical for cell signaling. And so, the phosphatase activity of VIP1 needs to be controlled to a normal level. So, how it can be done? As I shown here, the phosphatase dephosphorylate specific protein with the help of water molecule to release this phosphoric acid. So this is performed in a highly selective manner depending on the class of the phosphatase as well as the amino acid sequence present in the protein. In case of VIP1, with which I have worked, which is also known as PPM1D, that is protein phosphatase metal dependent 1D. This VIP1 phosphatase is a member of protein phosphatase 2C family of serine or threonine protein phosphatase. So this is very important information when it comes to the development of VIP1 inhibitors. This means that this VIP1 dephosphorylate either phosphoserine or phosphothreonine amino acid of the specific peptide sequence, and a dephosphorylated protein which, as I shown here, act as a substrate. Now, VIP1 dephosphorylates and inactivates several types of proteins which are critical for cellular trace response, which includes P38 MAP kinase, P53, and ATM. So Stress response is nothing but the molecular changes that cell undergo in presence in response to environmental pressures. And as I said, VIP1 has been shown to be overexpressed in various types of cancers, thus controlling or inhibiting VIP1 activity could be an important new strategy for therapeutic intervention to halt the progress of several different types of human cancers. So, as I mentioned in earlier slide that VIP1 dephosphorylate various substrates. So out of which one is p53 MAP kinase. So here you can see this is the p38 MAP kinase peptide sequence which has this phosphorylated threonine along with this phosphotyrosine, because we have shown that VIP1 prefers diphosphorylated peptide rather than monophosphorylated peptide. So interestingly, we found that if you replace this phosphothreonine to a phosphoserine by keeping phosphotyrosine intact, these substrate peptides no longer act as a substrate. Instead, it acts as a weak inhibitor. Although this resulted a weak inhibitor, this inactive version of phosphoserine containing peptide appears to still bind with the VIP1 and act as an inhibitor. So, based on this, one could say that substrate-based approach can be used to design VIP1 inhibitors. So, this confirms a proof of concept of substrate-based design approach for a VIP1 inhibitor development. And this laid the foundation to develop new VIP1 inhibitors as shown here, where with extensive modifications of various amino acids in the sequence, we showed that this cyclic thioether peptide has an inhibition potency with 0.1 micromolar. On the other hand, if you change this phosphoserine to homophosphorine, which results into highly selective but weak inhibitor. And details of this study can be found in these two biochemistry papers which will appear in 2006 and 2011. So basically here we have shown that VIP1 substrate can be used as a VIP1 inhibitor if you modify the specific amino acid which VIP1 dephosphorylate. So similar to the base 1 inhibitor, here instead of a ethylene transition state isosteres, we used a phosphorylated amino acid to block the activity of VIP1 phosphatase. In addition to this, we also developed some small molecules against this phosphatase where I performed an extensive structural modification in the central compound, which is basically divided into 4 parts: X1, X2, X3, and chain length modification. So in this compound, I perform an extensive structural activity relationship at each position and come up with a molecule which has improved inhibition potency. So overall summary of my inhibitor development strategy is as shown here in this slide, which shows that slight modifications at x1 leads to the loss in the activity, whereas the x1 has limited scope for the modifications. On the other hand, for x2 position, it's very critical to have a correct ring size and chirality, and which cannot be changed. On the other hand, x3 seems to be little bit tolerated with the small changes. And finally, the chain length. The small chain length has slight improvement in the activity. So overall, with this all the modification, when we started with the molecule Tm, which was having the IC54.93 micromolar, we came up with the molecule 26, which showed the improved inhibition potency with IC50.6 micromolar. So basically, I performed a extensive structure activity relationship study with this molecule to develop a new analogs which can be further used for testing in cell-based assay or in vivo enzymatic assay. So this was a brief information on my research which I carried out during my PhD and postdoc. Now, currently I am working with the similar kind of research where I am developing a peptide-based inhibitor targeting a sediate methyltransferase. I will not go into the details of this methyltransferase at this time. So now I think let's move to the second section of my talk, which might be an interest of most of you and would like to know more in detail. So, research trends in chemistry. So this is an interesting article recently appeared in Chemical and Engineering News under Expert Predict 2021's Big Chemistry Trends. So in these articles, several experts from the different fields has given their thoughts on what one could expect in 2021 as a trends in chemistry. So let's dive in it. So in the past few years, chemistry trends has been grown vastly, and so with this is the one of the article recently appeared in December 21st, which discuss the research trends in chemistry in 2021. So first trend, which is artificial intelligence. In the past few years, artificial intelligence has dominated the research landscape of many fields, and chemistry is no exception. When we need scientific results as fast as possible while keeping safe with social distancing, of course, so artificial intelligence plays a pivotal role. For example, SARS-CoV-19 protein structural determination and computational analysis. It was done very fast because with the help of computational softwares which can predict the protein structure or its folding. Even nowadays, one can perform and develop small molecule synthesis with the help of this artificial intelligence. If you check on the internet for the structural information of spikes protein of COVID-19, you will find abundant data thanks to the software developed to protein structure prediction. The second is the sensor development. To be honest, we are slowly getting surrounded by sensors such as fitness trackers and blood glucose monitors as a few examples. Then the third one, this is one I feel it's very important for not only in the chemistry point of view, but also for other fields as well. I I believe we will see a spike in interdisciplinary projects aimed to understand and preventing pandemic in 2021. For example, a biophysical chemist predicting virus sequence, atmospheric chemist designing masks, and synthetic chemist working on developing protease inhibitors or therapies such as vaccines. Then remote learning. Everybody knows nowadays in 2021, this is something which is trending and which deals with the encouraging the student learning and measuring more meaningful aspects of that learning will be a key development in chemistry education in 2021. Then water purification, research and development. Then climate change is one of the major issue which severely impact our future growth. So it needs to be addressed as early as possible. So there will be a trend in the recycling and renewable energy. Then with increasing world population, it will be challenge to feed everyone, and so food production and developing a new techniques in the food industry, it will be very valuable. And finally, but last but not least, nanoscience. It's starting from drug delivery to a nanocarbon technology. It will change overall way of thinking. So these are the more general examples of research trends in chemistry one could see in 2021 or upcoming years. But when it comes to the specially for the analytical, organic, or inorganic, or medicinal chemistry, I will say it's very vast field, and each and every section of science requires chemistry hand. And these trends are adopting from simply synthesizing small molecules or developing metal or chemical based synthetic methodologies or organic transformation to the synthesis of proteins or methodologies developing using organocatalysis or enzyme catalysis, or let's say green chemistry protocols like water as a solvent and performing organic reactions, or just you one could say that performing the multi-steps reaction in one pot, or hydrogen fuel cells for cars, or genomic sequencing for disease identification and prevention, CRISPR-Cas9 gene editing, designing and developing polypeptide nucleic acid, a synthetic analogs for DNA, development of high throughput screening methods and computational analysis to develop quick and fast novel techniques and therapies, so that it will save time as well as the efforts of chemists. So there are several research trends despite from the general point of view which can be grown in upcoming years. So next, let's see the careers in and out science. So this is the one presentation from 2010 articles which showed that unique transitions and emerging careers in science. So basically, if you look at the bigger picture, most of the early career research or permanent research staff, finally, it's only a 5%, 0.5% leads to the professor, or some 17% goes for the non-university research, whereas the overall 79.5% moved towards the career outside science. So now basically we know that, okay, let's, once we have the master degree, one could go for like either uh, company job, or they can transition themselves into a university or in some college. These two we are familiar with, and these are the very routine career opportunities we see once you join for like master, or once you finish your PhD or a postdoc. But apart from these two, there are some other opportunities for science which we could say outside science but still with the science. So it is a non-traditional career. So what are those opportunities? So these are the basically a unique transitions, and these are careers beyond non-university research really, and a non-traditional or alternate opportunities. So one should think that, okay, would this be a something I enjoy doing, or I should move from the routine academia or industry to a non-traditional career? So you have to make your decision wisely. And in this non-traditional career, there are several options one could think of. So the first is the science policy. So what is this? So science policy, or science for policy, or policy of science. So basically this deals with serving as a bridge between researchers and public via legislators, and it involves formalization of scientific stance, drafting legislation on scientific topics, and aiding legislators in decision making. And this requires transferable skills like time management, negotiation skills, writing skills. Science policy, keep it in mind that science policy is not limited to the government sector. Knowing the possible pathways is very important, and policy fellows in India can be in the government or in industry, in academia, in R&D centers, or simply think tanks. So this is the one which you could think of apart from the traditional careers. The next one is a research and grants management. So this deals with the managed complexity and change brought in by multidisciplinary larger scale projects in terms of funding and administration. And this position is something which bridges communications between funding body and researcher. And for this type of position, one must have good background in science, and you should have multidisciplinary research grant proposal writing experience, launching funding schemes, and you should able to conducting events and workshop, with this, one could go for research and grant management. Then third is chemistry patent law. So what is this? This is the law governing inventions, discoveries, which requires both technical and legal knowledge of the subject. For this, the required skills are how to review patent documents to ensure that science is solid. This is one important thing which you should know. Then, what to discuss with inventors or discoverers. How to ensure that technical part is in synchronize with the law requirement, and how to draft technical and legal aspects of the patent application like protection rights. So mostly it's deals with, as the name says, that chemistry patent law. This is mostly deals with the ensuring that whatever research has been done, it's fully documented, or this has been discussed appropriately based on the law requirement. And this is mostly, let's say, falls under like a drug development or vaccine development for the FDA approvals, all those type of things. Then the next is a program manager, science communication. This is nothing but it provides a service for scientific articles, like a translation of scientific articles, correcting it in a scientific perspective, provide inputs on the research article writings. Let's say you have expertise in Japanese as well as in English. So then you can edit and translate research papers or research articles as per their requirement in the scientific language. And there is a huge latent need for services to support English as a secondary language researchers. And well-known example for these services is a cactus. Apart from that, scientists also can communicate more effectively with the public on various issues such as climate change, pollution, and tell people why they should care. And the last but not least is entrepreneurship. In short, we can say it's a creating a new enterprise to address a requirement or problem and develop a new technique with a view of making profit. So we can say starting a small business or company with experience or expertise you have. So the last one needs more courage and some unique ideas which can be put forward as a business model. So for that, there are several things you have to keep it in mind when it comes to the entrepreneurship. So overall, all these five sectors have job opportunities, or one could think of non-traditional career which can be carried forward depending on personal interest. So as I shown here, there are number of opportunities, not only with the traditional options, but also non-traditional exciting opportunities. And I hope this brief introduction on future trends in chemistry research and career opportunities will help you to make your decision based on your interest in the field. If you have any questions or queries, you can reach to me on my LinkedIn account, or you can bring it to Dr. Bondwe, who will be always there to guide you on choosing your future career. Thank you very much for your kind attention, and I hope this will help you to shape your future career.
Thank you so much, Tagar sir. You have given such a nice and informative lecture to our students and participants. You have provided a lot of information about the recent research trends and opportunities. You have provided a lot of information about medicinal chemistry to our students. We are very thankful to you for giving such a nice presentation and explaining very well. So thank you so much, sir. And we would like to see you to live touch in with our students in future, so they can get ideas about the research. So thank you so much, sir. And next session I will hand over to my colleague Miss Gitanjali Bhunja ma'am. So ma'am, please continue with it.
Good morning everyone, and thank you so much ma'am. Myself Professor Bhunja Gitanjali from T.C.College Baramati, and today I am here to introduce our second speaker of today's international webinar, and it's my great pleasure to introduce his PhD degree from NTH University, Hsinchu, Taiwan. In 2011, he was awarded by Outstanding International Research Student Fellowship by Taiwan government, and in 2017 he was awarded by Ramanujan Fellowship by Government of India. In 2018, Government of India awarded him by Early Career Research Award, and he published 14 research articles in different journals. Dr. Dati sir is expertised in catalysis and organic synthesis, CH activation and methodology development. With this brief introduction, I request to Dr. Ramesh Dati sir to deliver his lecture. Thank you so much sir for giving such a valuable and informative lecture to all the attendees of today's webinar. Sir has given a lot of information about recent research trends and opportunities in chemistry. I hope all the attendees are very satisfied with this lecture and they will utilize the ideas and suggestions which are given by the Dr. Datir sir. Thank you so much.
Good morning to all of you. And before starting my this webinar, I will just share my screen to start with. So I believe that my screen is visible to you. And so before going further, I would like to welcome you all for this international webinar, which is entitled with the recent trends and the opportunities in chemistry, and organized by the Department of Chemistry of Tuljiram Chaturchanda College, Baramati. So and also, I would like to say good morning to those participants, especially the resource speaker like Dr. Harishchandra Tagad in USA, Dr. Vinayak Kale in Saudi Arabia, and Dr. Srinivas Reddy, scientist, which is he's in CDRI Lucknow, and also the professors from the Baramati College. So good morning, sir, and good morning to all of you. So and also, I will be very glad to be here. Unfortunately, we are not physically conducting these seminars or symposium or webinar because of this COVID-19 situation. But nevertheless, these online platforms nowadays are very much accepted at international and as well as the national level, and people are very much habituated with these technology. So to begin with, I think today's topic is kind of, or the webinar topic is kind of the mixing the two things, research trends and the opportunities in chemistry. So there are two section, I can say, the research trends, and the second section is the opportunities of the or opportunities in the chemistry. This is what I understand. So being the chemist, or being a researcher, or being the faculty in Jain University Bangalore, as you know from my introduction, so I have the very much broad experience with the different aspect, no matter it is the research related or academic related, or writing the thesis related, or writing the papers related. But what I feel that what students are expecting at this point, or what is the objective of this symposium, or the webinar. So with respect to these objective or titles, I just thought to gather or collect my slides, which are helpful for the students. So instead of going so much deep in the chemistry, what I did in the last decade, maybe I will go a little step down when I was pursuing my MSc. So but at the same time, I don't want to hide the things which I am doing currently, and which I did the couple of years back. So I prepare my slides in like a descending order. What I am doing currently, or in last 3-4 years, or last 5 years, that I choose to show you first, or that I thought to talk first, and then later, because once you grasp, or once you visualize the things which are remain to do after MSc, then you will have the idea what should be the way constructed, or what should be the ways to be implemented for the next couple of years, or the 5 years. Okay, because where you are thinking through to stop your education, from there only the education is going to begin. Okay, because the in the decade 1990 or the 2000, the MSc or MSc organic chemist has the much value. But later, when the education is developed, or the chances of getting employment is more complicated, then people are obviously looking for the higher education. And in that sense, what are the opportunities left over? So that I'm going to talk in next like a 45 minutes to 1 hour time. Okay, so sit back and relax, and just see the screen, and listen to my audio. Okay, so in the next slide, I just want to tell you that the introduction part is already going on, or is almost finished. So I'm going to show from next slide onwards is the research at abroad, what I conducted. Okay, so no matter what you understand, but I think being a chemist, or being a MSc organic chemistry students sitting here or watching here, I think they will understand what how the theoretical chemistry is to be implemented practically. Okay, and then the next point is the new research trends and opportunity. So the second point is the half section of the title, and then the third point onwards is the half section of your title of webinar, and then followed by the various competitive exam and various funded fellowship for research. Because being the students from the rural area, and being the student from the financially poor background, I think the fellowship or funded opportunity need to be implemented in upcoming years. And nevertheless, students after passing the MSc can also think for going abroad. So how to go, or how to approach research at abroad, that I'm going to tell you in few slides. Okay, so as Dr. Rahul introduced me in the beginning, I think I should skip this slide. But for your sake of convenience, I'm just briefly telling that currently I'm working in the Jain University as assistant professor, and also I was awarded by the Ramanujam Fellow by Government of India. And before that, I worked as a postdoctoral fellow in Oliver Bordwin's group in University of Basel, and before that, I worked as the postdoctoral fellow in South Korea, and before that, I also a postdoc in Taiwan, and in the same group I completed the PhD. And before that, I worked as a research associate in the Glenmark Research Center. And that time, I was working with Dr. Rahul Bhunve for around 2 years. So we developed our friendship over there. And before that, I completed. Master of Science in Pune University, and same university I completed BSc also. Okay, so what I did in the abroad country, so that I just want to show. So in the second postdoctoral research, I work on the CH activation. What is CH activation? Yeah, because if I talk this word, then I think you should know what is CH activation. The CH activation is nothing but the C and H bond is get activated by some metal. That means the metal is inserted between carbon and hydrogen to activate that carbon hydrogen bond for further synthetic application. That means the CH bond is cleaved and replaced by CX. So CX might be the any other species depending upon the reactivity of the compound. And why this is important? Because obviously the question will come that why CH activation is needed. So in that sense, if you can see this kind of starting material, which having the bromo group, and also the cyclic system, and also the various functional group, and if CH is free at this position, then palladium or any other metal can insert between C and H bond, and then CH activation strategy is implemented. And with this strategy, we can develop many kind of drug molecules. So all of you know the importance of the drug molecules in current scenario. So this CH activation strategy is useful for synthesis, various methodology, as well as the new drug molecules. So nevertheless, what I choose in my research is the nitrone substrate. Why? What is nitrone? Nitrone is the organic compound containing NO bond linkage. So, and how it will be prepared? That any aldehyde treated with the nitrobenzene in ethanol and in open air condition, we will get the nitrone formation. So nitrone is the highly polar atom transfer will take place. So if you can visit or if you can see these papers like OBC 2019, 2009, JOC 2015, and UCAM 2014, then you will came to know that how the oxygen atom transfer reactions are taking place. So when the metal is coordinated to the triple bond, the metal is activate this alkyne, and ultimately the oxygen is coordinated with the triple bond, and this kind of species will take formation of this kind of metal intermediate will take place. In the similar way, this kind of intermediate or the rhodium kind of Rhoda cycle will take formation of Rhoda cycle will take place. So in this way, not only in the metal catalyzed transformation, but also the cycle addition reaction, also the metal like nitrogen will take part, and to get this very important core of organic compound. So in 2000, I think 15 to 16, when I was in Korea, that time we implemented this nitrone chemistry for CH activation purpose, and for that purpose we use this nitrone with the rhodium catalyst and treated with the internal alkyne to get this Rhoda cycle, and ultimately it converted to the indole compound. So in this indole compound, the complete atom, economic and diastereoselectivity obtained. So I think those students are in MSc or BSc, so they will understand what is the diastereoselectivity. So and what is the importance of diastereoselective? compounds. So the diastereoselective compounds is highly medicinally important, and in this reaction, the dual role of rhodium-3 for CH activation and O atom transfer reaction is observed. And it is the first example of selective conversion of nitrones to indolines. And later on, we also tried the same reaction with the diazo substrate under the similar catalyst condition. We get the N-hydroxy compound formation, and in which the E1 and E2 is the symmetrical or as well as the unsymmetrical. So these are the highly important methodologies we developed and we published in very high impact journal in like a JACS and Ornick. So in these type of reactions are highly also useful for the synthesis of naturally occurring compound like tetracycle or tricycle or spiro compound and many others. So these are all medicinally important compounds. And later on, with this kind of nitron, we synthesized the various kind of library of the compound having the different substitution pattern, and at the same time, we also confirm the formation of this compound by taking the X-ray crystal diagram. So that will show you how the groups are oriented into the space. Okay, and at the same time, we also treated with the diazo, and then various substrate scope are obtained, and the key examples are summarized here. So this is with the nitron and how the mechanism take place, that the nitron will coordinate with the rhodium, and then the alkyne will comes into the picture, and the further coordination of rhoda cycle with the internal alkyne will take place to get this highly like a 7 to 8 membered the rhodocyclic species, in which are further undergoes the rearrangement to get this major and minor rhodocyclic species. So this major and minor is with respect to the position of pH and EH. So if the pH is the beta oriented, then it has the steric interaction with the CP group. So the formation of this type of rhodocycle, it might be the minor, and ultimately we are raised to the diastereoselectivity. So I think those are working in the research field, including some professor or my colleagues in this webinar. So they may, I think, have the idea how how this is happening. So because it is bit difficult for those students are in the BSc or MSc. So nevertheless, we also did the similar transformation using the diazo substrate, and reactivity is again similar, but this reaction is proceed either pathway B or pathway A. So the rhodium carbene formation take place, followed by again the rhoda cycle, which is lead to the formation of N-hydroxyindole under acidic condition, and the catalyst is recovered. So this is the mechanism. And before that, in 2014, what I did is we choose the enamide chemistry, or we choose the enamide substrate for the transformation. So what is the enamide? Enamide can be simply prepared with the bromoalkyne and the amine using copper catalyzer coupling is called as the enamide formation. So enamide, the name itself is telling that en means alkyne and amide means this kind of NSO2 or N whatever the electron withdrawing groups like TS, MS or any other electron withdrawing group. So this is the enamide system, and the enamide has a very prone to form the 1,3 dipole. So what is the 1,3 dipole, or how the 1,3 dipole is formed? Because this nitrogen lone pair comes here, and again this bond is shifting here to get the negative charge, and ultimately positive and negative charge will develop at 1,3 position. So this is the 1,3 dipole, and then the nucleophile will attack on this metal activated so-called allele, and then reduced selectivity will develop. So this is the beauty of enamide chemistry. So whole 4 years I work in Professor Raishan Liu's group at Taiwan, which is ranging on the enamide chemistry. So what further I used to do is like Uh, there are various papers I published which are summarized in various like a chapter number 1, 2, and 3. So where in chapter 1 what we did is like we treated enamide with the alkene, and here the terminal enamide is treated with the alkene, and based on the mechanistic aspect we are it leads to the formation of this kind of aromatic or like a non-aromatic heterocycle, not heterocycle but cyclic compound. And on the other hand, what we did, we treated this enamide instead of alkene, we treated with the nitro, and when we get the formation of 1,2-amino alcohol under the one-pot reaction condition, and this we published in JAX 2011. So this is a very good time for my research in the decade back. So and then in the chapter 3, what we did, we developed or we modified this the enamide to the in enamide. What is in enamide? In enamide means the alkyne and alkene. So this is in and YNE. So in ENE and YNE. So this in enamide, and it is treated with the N oxide. What N oxide is nothing but again the nitron. So the oxygen atom transfer take place and to get the furan compound. So this highly substituted furan we developed and that we published in ChemCom in 2012. Okay, so also we developed this 4+2 cycloaddition in which the enamide and alkene is reacted in presence of gold catalyst to get this aromatic compound, and various compounds we synthesize, and also these are the possible mechanism. And this mechanism with respect to the terminal enamide, and later this is the scope of reaction. I will not go much detail because I think the more important and interesting aspect of this the talk is still to come, because I just want to highlight my chemistry, what I did in the abroad countries. So this is the mechanistic proposal, and then in the second paper what we did is the nitron with the enamide. So again it is the mechanism, how the scenario has happened, because in the slide before I just summarizing the whole with only the scheme. Now here I'm showing the details how the mechanism will happen, and I will be happy to answer the questions at the end of this talk or later to explain you further. And then we also treated with the nitrosubenzene to get this 1,2-amino alcohol, and then it is the mechanistic aspect and the scope of reaction, and the application. That what is the application? That 1,2 say it's like a 1,3-amino alcohol or it's a 1,2-amino alcohol are important in the natural products. So this is what I make a circle here. So we synthesized this type of compound and published in the various journal. Okay, so this is 4+1 cycloaddition, and in 4+1 cycloaddition, as I said, in enamide. So this in and enamide is treated with the nitron or N oxide or quinoline N oxide to get the furan compound. Okay, so in this way, this is my PhD work when I was in Taiwan, 2009 to 13, I guess. And now, because I little rapidly I skip the slide, because those students are in MSc or BSc, they may not be have that much visualization or the understanding of this concept. But I still don't want to escape this from my talk, because students should get the idea what research is or what need to be done in the PhD. Okay, so now when I was in a broad country, so like from 2009 to let's say 17, around 8 years. So that research is different in the sense that facilities are different, and that facility is always facilitating my research. Now, when I came from the Switzerland to India in June 2017, and the next day I joined the Jain University, because there is not a single second gap of unemployment in my career. Correct. I stopped my postdoctoral employment in 31st of May 2017, and the 1st June I joined in Jain University as assistant professor. So there is not any gap. But that one day transaction changed my research theme dramatically. Correct, because I was working in very expensive chemistry. So what is expensive chemistry and inexpensive chemistry? The expensive in the sense that the material or the catalyst I use is very much expensive. But when I came back to India, the scenario is different. There is no funding or very less funding, or there is a lack of chemicals, there is a lack of facilities, there is a lack of infrastructure. So how to overcome it? I had a habit to do the chemistry which is very much high impact. But when I came here, I realized the problem what India is facing. So even though I had an experience of very high impact chemistry, but when I came back to India, I changed myself and I choose what people are looking for, or what society is looking for, or how make in India concept should be implemented in India. So in that sense, I changed the way of my research, and how I change my way of research, that is showing in this slide. Okay, because it is very less time to tell you all the things what I am currently doing, but this slide is telling you that what I am doing. Because if I exclude showing the research what I did in the abroad country, I may not be compare my current research, or I may not be comment with respect to my current research and what I did in the abroad. But in the last 10 slide, what you saw is, at least you understand that I use the gold catalyst, I use the rhodium catalyst, but these rhodium catalyst, 1 gram catalyst cost around 20,000 or 25,000 Indian rupees or even more. But I cannot borrow it because there is very less funding. Now, what I decided to prepare that catalyst instead of buying that catalyst. Not only the same catalyst, but any the transition metal implemented catalyst. So here I developed the palladium nanoparticle. For example, this is the title of my one of the PhD student research work. That palladium nanoparticle as an efficient catalyst for CH activation and CC coupling, ligand-free access to heterocyclic compound under mild reaction condition. Because I didn't leave my original research CH activation or CC coupling, but I changed this pattern like palladium nanoparticle. So what is this palladium nanoparticle? I prepare this palladium nanoparticle in home in the sense in my laboratory. So how I prepare? So this is called as a areca nut. Areca nut means in Marathi we can call supari. Okay, so this areca nut means that areca nut areca nut husk, that is outer cover of that nut. I mean supari. So that outer cover, when people take out that areca nut, that outer cover people will throw it like a coconut. We will just take the inside material and we'll throw all the trashes somewhere, and people can burn it, and that cause the extra pollution or the disposal problem. Correct. So what I decided, people only take a nut from this plant and they will throw all this garbage to somewhere, and it will take lots of time to decompose, or it will cause the pollution. So what I decided, I taken that the part which people used to throw. So there are many things I taken from the like a society that people not use, or people just throw it somewhere, and that will cause the extra pollution. And one of that is the areca nut husk. So areca nut husk means nothing but the outer cover of that nut. Nut in the sense I call nut as a supari. Okay, so that outer cover, when we dried in presence of sunlight, that will forms like the dried things. Okay, and then I added the ethanol water mixture and heated at 130 degrees Celsius or 80 degrees Celsius, that ethanol water that hold the organic phytochemicals from that husk will come into that ethanol water, and that I collected in the this beaker, and that later it will give the color like a brownish color solution. And in that I again take a one round bottle flask and I add the arecanut husk extract one side and palladium chloride at the other side. And when I heat it to 80 degrees Celsius for 1 hour, there is a very shiny black color palladium nanoparticle formation. And that palladium nanoparticle looks like this. Okay, so these palladium nanoparticle I used for the organic transformation. So what is the output? Output is from the trash to the very important metal catalyst. Because how I use this kind of catalyst, which is very expensive in a broad country, but here it is very cheap. Because I started from the things which people used to throw in the road or in the somewhere, so that is like environmentally harmful. So I use that material to develop the catalyst, and this catalyst is very interestingly working in my laboratory. So this is what we are doing in our lab. So this is what the mission so-called Make in India. Okay, so this is the things which totally fit the word of this webinar title, that research trends. Okay, so research trends means this is the thing, or this is the point where I am talking about. So these are the research trends people has to adopt in India, or people has to adopt for the economically the unstable situation. Correct. So this catalyst, once I develop, this catalyst has the several advantages with the homogeneous catalyst. Homogeneous and heterogeneous people use, I think you know. Homogeneous means catalyst is dissolved in the solvent, but heterogeneous catalyst is not dissolved in the solvent. Okay, so once that, for example, from A plus B using the catalyst convert to C, so that catalyst is after converting C can be taken out, and that can be used again. So there is no harm. If you put 100 mg of catalyst, you will get your product, and 99 mg of catalyst is recovered back. So that is the beauty of heterogeneous catalyst. So that these are the comparison of homogeneous and heterogeneous catalyst. So this is simple product purification, because heterogeneous catalyst very easily taken out by the filtration, easy recovery and reuse, less leaching and active species. So this is also the active species, and there is a various use for that catalyst, like water purification, fuel cell, biodiesel production, energy conversion, and medicine. Let me see how much time it is. Okay, so still there are 25 to 20 minutes are left. Okay, so I'm going to, so this is related to research trends I'm talking about as the halfway time. And now I'm talking about the research opportunities. Okay, so that now opportunities and approach. So that second part is opportunities and approach. What are the opportunities for research? Because if you are looking for going somewhere, you should know that what I have to do after going there. Correct. So that what you need to do, or what people used to do, or what experience people already done, is that what I talked in the 20 minutes back, or in last 20 to 25 minutes back. So now, how to jump from your MS to PhD, or how you can go for higher education, that I'm going to talk in next around 20 to 15 minutes. Okay. So there are various ways, and once people are graduated after did MSc or along with MSc, they will always used to thought UGC's NET and SET. What is the UGC NET and UGC SET exam? So UGC, it is the National Eligibility Test conducted by University Grant Commission. Okay, so University Grant Commission will conduct the UGC NET. What is the objective of that exam? Why UGC NET is required? There are many types of NET exam. The objective of JRF scheme is to provide the opportunity to NET JRF qualified candidates to undertake advanced study and research leading to the MPhil or PhD. I think MPhil program is discontinued from India, or going to be. So these UGC NET or NET JRF is useful for doing the PhD. And what is the eligibility? UGC NET is test countries in 94 subject appear for the UGC. And on the top of that, I can say the cherry on the top is you can try to think differently to jump from the India to the abroad country. So you have to think differently, prepare for competitive exam, and that competitive exam is not NET JRF, that is like a IELTS or TOEFL, these exams which are required for European country. Stay connected with the different university website. It's not like a Pune University or Aurangabad University. It's a university which are abroad. And search for the suitable program. So there are different programs in the fall, winter, or the autumn semester. So, and apply online, and then choose your advisor. You have to choose your advisor, communicate through the mail, and then make ready for your passport, and then get your visa, and then fly abroad. Okay, so this is also the dream actually. Okay, so what I mean that think differently. Think differently means what? Yeah, think differently means you should think that whether I'm really prepared for doing this, whether my financial background is okay, whether my family is needed, my physical presence with them, or if I am not came India back 2 years or 3 years, whether they can, they will be okay. So these all things you have to think in different way, and then if you suit for these things, then I think it's a good time to approach this. And I think there are the various expert faculties in your university, like Dr. Rahul and all, they have the experience how to do these all things. So I think you can approach him as well as other people like me or any of your seniors. So I think this is a good way to proceed further. Okay, so I think I talk more precisely on both the section. Both the section means our research in last decades, or last decade that covers from the today to till like 2009 or 2010. And research trend in the research, what research trend which I talk in between, like the developing the new catalytic system from the raw material or the cheap material which are environmentally helpful. That is kind of the